Let's take a look at your MT8 LT1 seminar. And what we're going to be looking at in this unit is similarity. So similarity, we've done our transformations. Now we're going to look at transformations where it's bigger or smaller. We're going to look today at dilations and scale factors. We're going to look what a scale factor is. And we're going to represent dilations as functions and find the scale factors of dilations. A non-rigid transformation is going to be bigger or smaller. We call that, in geometry, we call that a dilation. It makes it bigger or smaller. So if I have a shape, like let's say I take this triangle and I make it bigger. I make it bigger through what we call the center of our dilation. So I'm going to make it bigger through that. And what happens is, let's call this point O. What I'll do is I'll call this point A and this point A primed. And so my dilation we call K. If I can draw that, it's supposed to be straight. And what happened, A prime to O divided by A to O is going to be my scale factor, which, like I said, we like to use K in geometry. Whoops, didn't mean to do that. If you make it bigger, it's an enlargement. And what I mean by bigger, it's going to be bigger than 1. Okay? A greater than 1 is going to be an enlargement. Now, if we go between 0 and 1, that's going to be a reduction because all scale factors are going to be positive numbers. If it was negative, we'd be going in the opposite direction, and we're not going to do that yet. So if we take a look at our first example here, notice the direction. I'm going to go from triangle ABC to DEF. So I'm going to start at ABC. I'm going to become DEF. Notice that is going to be a reduction. Reduction means it's smaller. Now to find my scale factor, I take my image, which is 2, which is DE, and I'll divide that by the corresponding length in triangle ABC, which is 6. So 2 is to 6, so we get 1 to 3 is going to be our scale factor of our dilation. Now if we take a look at a design question here, it's kind of the same thing. It says, Jalal is printing a banner for his high school wheelchair tennis team based on the design shown. By what percent should Jalal enlarge his design so that the banner will be 5 times? Well, think, how do I write 5 as a percent? Well, that would be 500%, wouldn't it? Just move a decimal over 2 places. And then to find those dimensions, I'm going to multiply by 5. So to find the width, which is 6, I'm going to take 6 times 5. That'll be 30 inches. And then to find my length, I'll take my length, which is 14 times 5, and I'll get 70 inches. So length times width, so it gives me 30 inches by 70 inches. Now in geometry, a lot of times we like to look at the coordinate plane. So a dilation in the coordinate plane means I'm going to multiply the x and y by the same thing. That's provided my center is at 0, 0. On today's lesson, all our centers are going to be at 0, 0. We'll learn how to do it if it's not at 0, 0 later in this unit. So if I take a look here, my scale factor is 3. So if I pick one of my points, let's pick R. And I want to write the coordinate of R here. So R is over 2 and up 1. We can see that from our graph. We're at 2 and 1. So if I multiply by 3, R prime should be 2 times 3, which is 6, and 1 times 3, which is 3. Is R primed at 6 and 3? Sure it is. It's right there. So there is using our scale factors when we are at 0, 0.